Okay, so another short little video just to hopefully help sort some of this stuff out. So we have 5 lines and triangles, but we only have a handful of mathematical things that we do with those. So what I have here is triangle ABC with midpoints E, D, and T. So the first line in triangle that we talked about was a mid-segment, and a mid-segment doesn't go to one of the vertices. These are the vertices. A mid-segment simply connects two midpoints. So if I connect two midpoints, then that's the one where the mid-segment ends up half as long as the side it's parallel to, and it is also parallel to it, which I just said. So mid-segment connects two midpoints, half as long. So I would either take this length and double it to get this one, or I would take this length and cut it in half to find that one. All right, so mid-segments, one connects two midpoints. The shorter one is half the length of the longer one. Then we looked at the angle bisectors. So an angle bisector bisects an angle. Now if we draw all 3 angle bisectors in there, that creates the incenter, and the incenter is the center of that inscribed circle. And that's a definition and that's vocabulary. But the math that comes with it is if I have a single angle bisector, that's when I get proportional lengths. So whatever this length is over this little piece is proportional to whatever this length is over this little piece. So if I have an angle bisector, one angle bisector, I create proportions. So 10 over 3 equals 12 over x. And remember, the order that you use to write your first ratio, you have to use that same order for the second ratio. So when I say 10 over 3, I stayed on this side of the bisector. I said whole side over piece of side is equal to whole side over piece of side. There are other ways to set up that proportion, but just use consistency. Then the third line that we did, that one was the one that produced the center of balance, or the centroid, and that was connecting a midpoint to a vertex. So when I connect a midpoint to a vertex, that's when I get the 1:2 ratio, where the one piece of the median that's between the centroid and the vertex is 2 times longer than the segment from, or the section from the centroid to the midpoint. So if this is 3, this is 6. If this is 10, this is 5. If this is 24, this is 12. Okay, but it also, so that's the relationship between the two pieces as measured from that centroid. But if I look at the entire median is 36. The short part is 1/3 of 36, or 12, and this is 2/3 of 36. So when I compare a piece of that median to the total, it's either 1/3 of the total or 2/3 of the total. So that is what we did with medians. And then there are the two where we have right angles. The first one was an altitude, and an altitude simply measures the perpendicular length from a vertex to the opposite side. It's going to make a 90-degree angle. The only thing we did with altitudes was Pythagorean theorem. I told you there was going to be Pythagorean theorem in every test. So here's where I can use a Pythagorean theorem. But again, I have to have a right triangle. So the altitude gives me the right angle, and it gives me 2 right triangles. And I can use Pythagorean theorem on both of those right triangles. Remembering that when I do a squared plus b squared equals c squared, c is always the hypotenuse. So for that right triangle, this length would be the hypotenuse. For this right triangle, this length would be the hypotenuse. So the intersection of the altitudes, because I have 3 altitudes, their intersection is the orthocenter. That's the one new word that I said I put in OneNote, and I also put it in the Quizlet, so you do need to remember that vocab term. The others, we all put in our notes together. And then the final one's the perpendicular bisectors of the side, so I have to go through the middle of the side at a 90-degree angle, through the middle of a side at a 90-degree angle, and through the middle of the side at a 90-degree angle. Okay, so the perpendicular bisectors, the only thing that you need to remember about them other than recognizing them is that that is the center of the circumscribed circle. That is the circumcenter of the triangle. So hopefully that helps you sort it out. Okay, have a good afternoon.